Today we're going to show you how to carry out a continuity test using what the on-site guide calls method number 1. Before we do this, want to again remind you that because we're doing a continuity test, we need to use what we call a low ohm meter. Again, they come in many shapes, sizes and forms. This is a fluke meter. And again, on some of these, it doesn't have the ohm sign, it will have continuity on there. Mine is already set to continuity. I'm going to switch it on, and we've already calibrated this machine. Again, I'm just going to test that this machine is functioning as best as we can, and in order to do that, what I'm going to do is just put my two leads together. This you always need to do. I have two test buttons. I can choose which test button to use, one on my actual prong itself or one on the actual meter here. I'm just going to use the one on the test button. Now I've created a circuit here, so I'm expecting a low reading, and I have a very low reading. It's 000, which means that my meter has what we call nulled the leads. So when I take my R1 plus R2 reading, my meter leads are not going to become part of that reading. And again, second test I would do is I would give the machine an open circuit. And so an open circuit is a circuit that doesn't have continuity, and I'm expecting this to be a very high reading. And again, I've got 2000 ohms, very high reading. As far as I'm concerned, my meter is functioning correctly. Having established that, what we want to do now is, and again, like with the R1 or R2 test, we start at the origin of the circuit and we end at the furthest point of the circuit. Now the furthest point of this circuit will be the actual light fitting itself. And so in order for me to start, what I want to do is access my R2 cable and access my R1 cable. Now R1 stands for resistance 1, R2 stands for resistance 2. R1 will always be your line conductor. R2 will always be your CPC conductor. And if you just look in here, we're not going to do that today, but Rn will be your neutral conductor, your resistance neutral. And so this test requires us to use R1 plus R2. Now we would use this test over the R2 test because it does have some benefits. One of the major benefit of this test is if we test this way, we actually are at the same time testing what we call polarity. And so what that means for us is it saves us a test. So if we can test continuity by testing the R1 plus R2 method, then at the same time we test polarity, which means we save time. So I know in this circuit that my line and my CPC start here, and I know they finish at the light point. In a realistic situation, this will be, let's take a domestic house. This might be in the basement, and your last light point might be the top floor in somebody's bedroom. Now I don't have a wander lead, so I can't use the R2 method. And so what I would now want to do is actually use the R1 plus R2 method. I'm actually going to use the cables inside the circuit to actually be my test wires. That's what I'm actually going to do, and it's really convenient to actually do it this way. The difference by doing it this way is that because we are testing two cables, we will have a slightly higher reading, and also we'll have a slightly higher reading because the line cable has to go through all of the switches before it gets to the actual light point itself. So what I would normally do at the CCU end is I would connect my line and my neutral, or my line and my CPC together. Now in connecting them together, I'm actually potentially making a circuit. So I'm connecting just a connector block, make sure they're tight in there. I know that the end of this lighting circuit is that light. And so in order for me to test my R1 plus R2, I'm going to go to my light point, because my light point is the end of circuit. And again, I'm going to, I can do it a number of ways. I think I'm just going to take the crocodile clip off. That'll be easier for me. This is my last light point, and just want you to beware that I have again crossed my line and my CPC, and so what I want to do is actually find it at the last light point. The whole idea of continuity again is for me to check that these things are continuous. So what I'm going to do is put one of my leads across the line and one of my leads across the CPC. Now, you must remember that when it comes to the line conductor is actually going through the switches. It's quite possible that this actual lighting circuit is actually switched off. So I'm going to do a test, and if I get an open circuit, then I know that one of these switches is switched off, and I'll need to switch the switch on. So I'm going to do this test now. Now, if you look at my meter, I've actually got 2,000 ohms. Now, I'm not worried about that because I realize this is a lighting circuit, and this light will never work unless I switch one of these switches on. And so this means I've got an open circuit. So what I'm going to do is switch one of those switches on and do the same test again. Aha. So now, having done that test, I have a test result of 2.66 ohms. Now, there are 3 switches in this lighting circuit. Now, in order for me to test my polarity while I'm testing my continuity, what I'm going to do is switch all the switches one at a time. And so I know it's in the on position at this moment in time. And so what I'm going to actually do is just switch that one, and I should now get what we call an open circuit. Absolutely great. 2,000 ohms there. I've switched the lights off. That's all I've done. Now there's a third light switch here. I'm going to switch that one. And now I should again switch the lighting circuit back on. Doing the test. Now this test here has given me a test result reading of 3.07. My last test reading was 2 something. And what I would do is on my schedule of test results, I would want to put the highest reading that I have obtained within the switch combination. And so what I have just determined here is that my R1 and my R2 are continuous, and at the same time, by switching the switches, I've actually checked my polarity as well. Thank you.